Level 1. The crocodile paradox. A parent stands by a river as a crocodile takes their child. The crocodile says it will return the child only if the parent correctly predicts what it will do next. The parent answers that the crocodile will not return the child. The moment that answer is given, both are trapped in logic. If the crocodile keeps the child, the parent's prediction turns out to be correct, which means the crocodile must return the child as promised. But if the crocodile returns the child, then the prediction becomes false, which means the crocodile should have kept the child instead. Each option destroys the condition for the other. This paradox shows how rules that depend on prediction can loop back on themselves. Every outcome depends entirely on the truth of another action that cannot happen at the same time. Logic, when turned inward, loses stability and creates endless contradiction. The situation has no consistent ending. Every resolution reverses itself the moment it appears true. Level 2. The ship of Theseus. A ship is repaired piece by piece. Over time, every plank, rope, and nail is replaced. When no original parts remain, the question arises, is it still the same ship? If someone later rebuilds the ship using the discarded parts, two versions now exist. Both claim to be the original. The paradox examines what defines identity. If something's physical components make it what it is, then the rebuilt version, using the old materials, should count as the true ship. But if identity depends on continuity, history, or function, then the constantly repaired one holds that title. The logic works both ways. This problem appears simple, but reveals how words like same and original rely on unseen rules. Identity can be seen as matter, memory, or purpose, and each gives a different answer. The paradox stays open because no definition includes every possibility. The question remains balanced between physical change and conceptual continuity. Level 3. The grandfather paradox. A person travels back in time and stops their grandfather from having children. If that happens, the time traveler is never born. But if the traveler is never born, they cannot go back in time to stop it. The event undoes itself the moment it occurs. This paradox deals with cause and effect. Every event depends on another to exist, yet here one destroys its own foundation. The result is a logical loop in which time cannot hold both outcomes. Each explanation contradicts the other, yet neither can be dismissed. In physics and philosophy, this raises questions about whether time travel could ever be consistent. Some theories suggest parallel timelines where both realities exist independently. Others argue such contradictions prove time travel into the past is impossible. Both approaches accept that standard cause and effect cannot handle self-cancelling actions. The paradox remains unbroken. The moment of interference erases the reason for itself. Level 4. The trolley problem. A runaway trolley races toward 5 people tied to the track. You can pull a lever to divert it onto another track where one person stands. Doing nothing means 5 will die. Acting means 1 will. The question asks, what choice is right? The paradox sits in moral reasoning. Both actions can be justified. Pulling the lever saves more lives, yet it also makes someone directly responsible for another's death. Refusing to act avoids personal guilt, but it allows greater harm. No option feels purely correct. It illustrates the clash between utilitarian thinking, maximizing total good, and deontological thinking, avoiding active harm. Each framework gives a different answer while both seem rational. Real-life choices often mirror this tension in law, medicine, or military ethics, where saving many may require harming few. The scenario ends with unresolved discomfort. Morality offers reasoning, not certainty. Level 5. The omnipotence paradox. If a being can do anything, can it create a rock so heavy that it cannot lift it? If it can make such a rock, then there is something it cannot do, lift it. If it cannot make the rock, then there is something it cannot do, create it. The idea of unlimited power collapses when applied to itself. This paradox exposes how absolute concepts contain hidden limits. When power extends to every possible act, it begins to include contradictions. The act of creating a task that negates one's own power becomes both possible and impossible at once. The problem is linguistic as much as logical. Words like everything assume consistency, but contradictions destroy meaning when pushed too far. Philosophers and theologians use this paradox to show that even divine or infinite concepts cannot escape logical structure. The contradiction stands as a reminder that total power cannot include impossibility itself. Level 6. The Liar's Paradox. Berson says, "This statement is false. If the sentence is true, then it must be false. If it is false, then it becomes true." The statement flips endlessly between the two without resting in either state. This paradox reveals how language can trap itself. A simple sentence that refers to its own truth cannot hold a stable value. Logic depends on consistency, but self-reference destroys that foundation. The liar's paradox shows how any system that allows self-description risks collapse. If language can claim its own falsity, there is no fixed point to decide truth. Mathematicians and logicians have built entire frameworks like Gödel's theorems around this same kind of self-reference. Truth, in this case, becomes undefined. The sentence exists, but its meaning cannot settle into one side. Level 7. The Unexpected Hanging Paradox. A judge tells a prisoner that they will be executed on a weekday next week, and that the day will be a surprise. The prisoner reasons through the days. It cannot be Friday, because by Thursday night they would know. If Friday is excluded, then Thursday cannot happen either, and so on. By logic, no day fits the rule. Yet, when the hanging occurs on a Wednesday, the prisoner is shocked. The paradox arises because correct reasoning produced a false conclusion. The very process of deduction removed the real possibility of surprise, yet the surprise still happened. This paradox demonstrates the limits of reasoning when it interacts with human knowledge. Predictability itself changes the situation being predicted. The more the prisoner analyzes, the less the result aligns with that analysis. The paradox stays unsolved because both the reasoning and the outcome remain valid at the same time. Level 8. The Paradox of Tolerance. If a society tolerates every belief, it must also tolerate those who oppose tolerance. But if it accepts intolerant ideas, those ideas will eventually destroy tolerance itself. Full openness leads to its own end. This paradox lies within social balance. To remain tolerant, a society must sometimes refuse behaviors that seek to remove tolerance from others. Yet, doing so means setting limits, which seems to contradict the idea of tolerance. Each principle depends on restricting the other. Philosopher Karl Popper described this as a warning about democratic systems. Allowing unrestricted intolerance allows hostile ideologies to grow until they remove the freedom that permitted them. Maintaining openness requires boundaries. The tension never disappears. Tolerance must defend itself by sometimes refusing what would destroy it. Level 9. The Bootstrap Paradox. A scientist receives a blueprint for a time machine from their future self. They use it to build the machine, then later travel back in time to give the same blueprint to their younger self. The question becomes, who first created the design? The paradox forms a closed loop without an origin. The blueprint exists, yet it was never invented or discovered. It simply passes between versions of the same person forever. The cause and effect cycle sustains itself with no beginning. This challenges how time and information work. In normal conditions, knowledge must have a source. Here, the source is erased. Time travel in fiction often uses this paradox to explore causality and the illusion of creation. Every action becomes both result and cause. The loop continues endlessly, containing itself as its own explanation. Level 10. The twin paradox. Two twins are identical in every way. One boards a spacecraft and travels near the speed of light, while the other stays on Earth. When the traveler returns, they are younger. Both experience time normally from their own view, yet the comparison shows a real difference. This paradox arises from Einstein's theory of relativity. Time slows down for objects moving at high speed relative to others. From the traveler's perspective, it seems the stay-at-home twin should have aged less instead. Each frame of reference feels correct. The explanation lies in acceleration and motion. Only the traveling twin changes frames, breaking the symmetry. Physics resolves the math, but the intuition remains confusing. Everyday life teaches that time is uniform, yet relativity proves it stretches and contracts with motion. The twins reunite with different ages, showing that both realities are true within their own frame. Level 11. The Sorite's paradox. A single grain of sand is not a heap. If adding one grain cannot turn something that is not a heap into a heap, then no number of additions ever will. Yet, at some point, a pile clearly becomes one. The transition point cannot be defined. The paradox shows how vague terms create logical problems. Words like heap, bald, or rich lack sharp boundaries, but reasoning assumes precision. When logic meets language built on approximation, contradiction appears. It challenges how categories work. If gradual change can never make a difference, then nothing ever changes in kind, only in degree. But human understanding depends on thresholds, even when those thresholds are arbitrary. The problem remains open because real life forces clear answers, where logic offers none. Level 12. Schrödinger's cat. A cat is placed in a sealed box with a radioactive atom that may or may not decay, triggering a mechanism that kills the cat if it does. Until the box is opened, quantum theory says the cat exists in both states, alive and dead at once. The paradox exposes the gap between quantum mechanics and everyday experience. In theory, particles can exist in multiple states simultaneously, but when observed, the system collapses into one definite outcome. The cat represents the conflict between superposition and observation. It raises the question of when and how reality becomes definite. Is it the act of measurement that changes it, or was it always one way? The experiment is imaginary but defines a real problem in physics. The cat remains both alive and dead in thought, until observation forces one result. Level 13. The Pinocchio paradox. Pinocchio says, "My nose will grow now. If it grows, then the statement was true, meaning it should not have grown. If it does not grow, the statement was false, meaning it should have." His nose's behavior becomes logically impossible. The paradox applies the liar's contradiction to a physical consequence. A statement about itself creates a feedback loop where both outcomes make the statement wrong. Unlike the liar's paradox, this version links truth to a visible action. It demonstrates how contradictions arise when rules of logic meet real effects. Every possible result cancels the truth condition that caused it. In theory, Pinocchio would be trapped in a state of logical suspension. The cycle cannot resolve because both outcomes depend on the same condition being true and false at once. Level 14. The decision maker's paradox. Someone must choose between two identical options, such as identical products or perfectly balanced outcomes. With no difference to guide the choice, there is no rational reason to pick either. Yet inaction also feels irrational, since some choice must occur. The paradox lies between freedom and reason. Total equality removes justification, making decision impossible, but real choices still happen, revealing that reason alone cannot explain behavior. It shows the limit of rational decision theory. When all variables are equal, choice becomes arbitrary, yet life requires action. This same problem appears in economics and artificial intelligence, where systems can loop endlessly when faced with identical options. Choice without reason exposes how logic needs asymmetry to function. Level 15. Zeno's arrow paradox. Zeno argued that an arrow in flight is motionless at every instant of time. At each moment, it occupies one fixed position. Since time is made up of moments, and in each it is still, motion should be impossible. The paradox challenges how movement is described. Breaking time into infinite points removes the continuity that makes motion real. If motion depends on occupying a new position, but every instant is static, then travel cannot occur. Modern calculus explains this by treating time and position as continuous rather than discrete. Still, the logic shows how division of reality into infinite parts can make change vanish through reasoning. The arrow flies, yet logic insists it never moves. Level 16. The barber paradox. In a town, a barber shaves all men who do not shave themselves, and only those men. The question is, who shaves the barber? If he shaves himself, he breaks the rule. If he does not, he also breaks it. This paradox, proposed by Bertrand Russell, illustrates self-reference in set theory. A definition that includes itself creates contradiction. The rule collapses because its condition cannot consistently apply to every member, including the barber. It reflects how self-contained systems can destroy their own logic. When something is defined in terms of itself, both inclusion and exclusion fail. The barber exists as a logical impossibility, not a real person. Level 17. The raven paradox. A black raven supports the idea that all ravens are black. Logically, a green apple also supports that idea because it shows that something not black is not a raven. Yet, that feels absurd. This paradox tests how evidence works. In logic, one counterexample disproves a general statement, so any consistent example should confirm it. But in practice, only direct evidence seems meaningful. It shows that logic and intuition value evidence differently. Formal reasoning treats all consistent observations equally. Human reasoning weighs relevance instead. The paradox remains as a question about what counts as genuine confirmation. Level 18. The paradox of choice. Having many options feels like freedom, but too many can cause paralysis and regret. People with fewer choices often feel more satisfied than those with endless possibilities. The same freedom that promises happiness can lead to dissatisfaction. The paradox comes from expectation and comparison. More choices raise the standard for success, increasing the chance of disappointment. Every selection implies rejecting many others, which adds doubt and second-guessing. It demonstrates that maximizing opportunity can reduce peace of mind. Rationally, more options should always help, but emotionally, they complicate decision-making. The freedom to choose can make satisfaction harder to achieve. Level 19. Russell's paradox. In set theory, consider the set of all sets that do not contain themselves. If it contains itself, it violates its own rule. If it does not contain itself, then it must contain itself to fit the definition. Either outcome breaks logic. Russell's paradox revealed flaws in early mathematics. It showed that unrestricted self-reference leads to contradiction. Mathematicians later restructured set theory to avoid such definitions, forming the basis of modern logic. The paradox remains important because it defines the boundary of what can be consistently described. Any system that allows total self-reference collapses under its own rules. The contradiction stands as the core example of logical inconsistency. Level 20. The infinite hotel paradox. Imagine a hotel with infinitely many rooms, all occupied. When a new guest arrives, the manager moves the person in room 1 to room 2, room 2 to room 3, and so on. Every guest still has a room, and space is made for one more. This paradox, also known as Hilbert's Hotel, shows how infinity breaks normal intuition. In an infinite system, Adding or removing parts does not change the total. Even if infinitely many new guests arrive, the manager can still fit them by moving each person to a room twice their current number. It demonstrates that infinity is not a number, but a concept beyond counting. Arithmetic rules fail when applied to it, yet mathematics remains consistent under new definitions. The hotel never fills, because infinity has no end or limit. Level 21. The Bootstrap Universe Paradox. Some cosmological models suggest the universe could create itself. A future version might generate conditions that cause its own past to exist, forming a closed loop of time. The universe would become both the cause and effect of itself, erasing the need for any external origin. The paradox lies in self-causation. If the universe brought itself into existence, then it existed before it began, violating the normal order where causes precede effects. Time, in this view, would not flow linearly from past to future, but instead form a self-contained circle. This idea raises deep questions about the nature of existence. If time is cyclic, every event could feed back into its own creation. Some physicists and philosophers consider this a possible model for universes governed by closed time-like curves. Others see it as a breakdown of the concept of causality itself. The paradox remains unsolved because it challenges the most basic assumption that something must come from something else. Level 22. The Catch-22 Paradox. A soldier may be discharged for being insane, but must request the discharge to qualify. Making the request proves sanity, which cancels eligibility. Refusing to request keeps them in service. The rule traps them in a loop with no escape. The Catch-22 Paradox describes circular reasoning built into bureaucracy. Each condition relies on the other to deny both. The regulation enforces its logic perfectly, leaving no consistent way to meet its own requirements. The term now represents any system where escape or success becomes impossible through its own logic situations, where both action and inaction lead to the same outcome. In real life, it mirrors red tape, policy contradictions, and institutional paradoxes. It captures how rules designed for control can trap logic within itself until no outcome remains free. Level 23. The Paradox of the Stone. If a being can do anything, can it create a stone so heavy that it cannot lift it? If it can make the stone, there is something it cannot do, lift it. If it cannot make the stone, there is also something it cannot do, to create it. Both options deny total power. This paradox exposes the limits of absolute ability. The phrase, "can do anything," seems simple, but includes contradictions that cannot exist in logic. True omnipotence cannot involve doing what is self-contradictory, like making a square circle or lifting what cannot be lifted. It clarifies that infinite power must still operate within logical consistency. The problem is not with power itself, but with the meaning of the words describing it. A definition without limits collapses when it meets contradiction. The paradox remains as a boundary, where language and logic refuse to merge. Level 24. The Lottery Paradox. In a fair lottery with 1,000,000 tickets, it is reasonable to believe any one ticket will lose. But since one must win, it is unreasonable to believe they all will lose. Rational beliefs held individually become irrational when combined. The paradox reveals a clash between probability and certainty. Each judgment on its own makes sense, but when applied to all cases, it produces contradiction. Believing something probably false for each instance leads to an impossible conclusion for the set. This reflects limits of probabilistic reasoning. Logic assumes consistency, but probability measures expectation. A belief that works statistically may not hold universally. The gap between reason and logic becomes clear when scaled to many cases. The paradox stays unresolved because the rules for single belief and collective belief cannot coexist perfectly. Level 25. The Unexpected Examination. A teacher tells students there will be a surprise test next week. The students reason it cannot be Friday, because if no test occurred by Thursday, they would expect it. That same reasoning removes Thursday, then Wednesday, and so on, eliminating all days. When the test happens midweek, they are shocked. The paradox shows that correct reasoning can still produce wrong expectations. The logic of eliminating each possibility depends on knowledge that changes when new events occur. The conclusion fails not because it is irrational, but because awareness affects outcome. It illustrates how prediction interacts with self-reference. The very act of anticipating the surprise changes the conditions that make surprise possible. In logic, this creates a loop where knowledge invalidates itself. The test occurs as planned, yet logic insists it cannot. Level 26. The Epimenides Paradox. Epimenides, a Cretan, said, "All Cretans are liars. If he tells the truth, then his statement makes him a liar. If he lies, then some Cretans must tell the truth, meaning his statement is false. The sentence turns on itself until truth and falsehood lose meaning." This paradox is one of the oldest examples of self-reference. It reveals that statements about entire groups can fail when they include the speaker. Logic collapses because the claim cannot exist outside its own contradiction. It led philosophers and logicians to study how language can create unsolvable feedback loops. Similar patterns appear in mathematics, semantics, and computer theory wherever systems describe themselves. The paradox remains a mirror, reflecting how truth breaks down when it folds inward. Level 27. The Fermi Paradox. Given billions of galaxies, each with countless stars and planets, intelligent life should be common, yet no clear evidence of other civilizations exists. The contradiction between probability and observation is what physicist Enrico Fermi questioned: where is everybody? The paradox stands between expectation and silence. Statistically, life should have appeared many times. The absence of signs, no signals, artifacts, or visits contradicts that assumption. Possible explanations range from isolation, destruction, or advanced restraint to limits in how we search. It forces reconsideration of what common means on cosmic scales. The vast distances, timescales, or rarity of intelligence might explain the gap, or it might reveal human bias in defining detectability. The question endures because the evidence remains empty while the probability remains high. Level 28. The Paradox of the Plank. Two shipwrecked people cling to a single plank that can only support one. If both hold on, it will sink, and both will die. If one lets go, the other survives. The situation forces a decision where every action feels both necessary and wrong. The paradox explores the conflict between moral duty and self-preservation. Choosing to save oneself means allowing another to die, while refusing to act leads to shared destruction. Both choices can be defended, yet neither can be justified without contradiction. It raises questions about whether moral responsibility ends when survival is threatened. Law and ethics often differ here. Some traditions excuse self-preserving acts, while others see them as moral failure. The paradox shows how reason alone cannot balance instinct and obligation. The dilemma ends without moral closure, caught between logic and human necessity. Level 29. The Sleeping Beauty Paradox. Sleeping Beauty is put to sleep on Sunday. A fair coin is flipped. If heads, she is awakened once on Monday. If tails, she is awakened on both Monday and Tuesday, but her memory is erased after each awakening. When she wakes, she knows these conditions, but not what day it is. She must estimate the chance that the coin landed heads. One argument says the probability is 1/2, since the coin is fair. Another says 1/3, since under tails there are 2 awakenings for every one under heads. Both use correct reasoning, but count different kinds of evidence. The paradox questions what it means to assign probabilities to self-locating experiences. When knowledge and perspective mix, Probability no longer measures only external events. The reasoning divides evenly, and both interpretations stay logically consistent. Level 30. The two envelopes paradox. Two envelopes contain money. One holds twice as much as the other. After choosing one, you are offered the chance to switch. Reasoning shows that switching might always increase your expected gain, since there's a 50% chance the other envelope contains double your amount. The paradox appears because the expectation calculation lacks a fixed reference point. Each estimate assumes the unknown value represents the smaller or larger amount equally, which leads to an infinite loop of switching. The logic supports an endless desire to change choices despite identical odds. It exposes how mathematical reasoning can mislead when applied to incomplete information. Probability without boundaries produces meaningless comparisons. Economists and philosophers use this paradox to show that expectation depends on context. The envelopes remain sealed, each holding a value that logic can never settle. Level 31. The Monty Hall Paradox. A game show presents 3 doors. Behind one door is a prize, and behind the other 2 are empty spaces. The contestant chooses one. The host, who knows where the prize is, opens one of the remaining doors to show it's empty. The contestant must now decide whether to stay with the first choice or switch to the last unopened door. At first it feels like there's a 50-50 chance, but that intuition is wrong. The original choice had a 1 in 3 chance of being correct. The other 2 doors together held a 2 in 3 chance. When the host opens one, that probability shifts to the final door. Switching increases the chance of winning from 1/3 to 2/3. The paradox reveals how conditional probability challenges intuition. People treat each step as equal when new information actually changes the situation. The logic stays clear, but instinct resists it. The paradox shows that mathematical truth can conflict with human perception. Level 32. The Abilene Paradox. A family decides to take a trip to Abilene on a hot day. Everyone agrees, thinking the others want to go. After hours of travel, they realize none of them actually wanted the trip. Each person acted to satisfy what they believed others preferred, but no one truly did. The paradox demonstrates how social harmony can create collective mistakes. Everyone avoids disagreement, yet the group's silence forms a false consensus. The desire to maintain peace replaces honest expression, producing outcomes that satisfy no one. It appears in business, politics, and family life whenever individuals suppress their views to align with what they assume others believe. The group acts together under mutual misunderstanding, not agreement. The paradox exposes how cooperation can fail when honesty is avoided. Consensus, once thought to mean unity, can instead reveal universal misjudgment. Level 33. The Mind Upload Paradox. Imagine a person's entire brain scanned and perfectly reproduced inside a computer. The digital version remembers every event, emotion, and thought. It speaks, reacts, and believes itself to be the same person. The original body dies, but the program continues as if nothing changed. The question is whether this continuity is survival or imitation. The paradox questions what makes someone the same person over time. If identity depends on memories and mental patterns, the copy qualifies as identical. But if identity depends on unbroken conscious experience, the copy is new and separate. Both arguments follow logic, but lead to incompatible conclusions. It challenges definitions of selfhood, raising problems for philosophy, neuroscience, and future technology. When identity becomes data, the concept of death loses clear meaning. The paradox remains unsettled because both interpretations of identity, continuity, and consciousness cannot exist together. Level 34. The Arrow of Time Paradox. The equations that describe physical motion work both forward and backward, yet time in experience flows only one way. A glass can fall and shatter, but never reassemble itself. We remember the past, never the future. Nothing in fundamental physics demands this direction, yet it appears absolute. Scientists often relate this to entropy, a measure of disorder. Entropy increases as systems evolve, marking time's forward motion. But entropy is statistical, not causal. It describes what tends to happen, not what must. The paradox lies in how reversible laws create irreversible experience. It also raises the question of perception. If the universe allows time to run either way, why do we only observe one? The explanation might depend on the universe's beginning or on the limits of observation itself. The paradox stays open because physics explains time mathematically, but not experientially. Level 35. The teletransportation paradox. A teleportation machine scans a person, records their physical structure, destroys the body, and reassembles an identical copy at a new location. The new version opens their eyes, remembers everything, and believes they have traveled, yet the original ceased to exist. The paradox asks whether this process preserves life or replaces it. If identity depends on physical continuity, the traveler dies, and the copy is only a replica. If identity depends on mental content, the person survives unchanged. Both lines of reasoning make sense, but cannot both hold true. The paradox divides experience from matter. It highlights the gap between information and existence, showing how technology challenges our concept of self. The person at the destination acts like the original, but may not be the same conscious being. The paradox stays unresolved because logic offers two complete answers that exclude each other. Level 36. The paradox of tragedy. People seek out art that makes them sad. They watch heartbreaking films, read tragic novels, or listen to sorrowful music. These experiences bring sadness, yet people value them deeply. The paradox asks why pain can become a source of satisfaction. Some say tragedy provides emotional release without real loss. Others argue that sadness offers understanding, letting people confront feelings safely. Both explanations help, but fail to capture why the same emotion can hurt and please at once. The paradox shows that emotion and reason operate on separate rules. Pleasure does not always come from comfort. Sometimes meaning itself becomes rewarding, even when it involves pain. The same emotion can carry both distress and insight. The paradox remains open because sadness can be both unpleasant and desirable at the same time. Level 37. The paradox of the court. A law student promises to pay his teacher after winning his first case. The student never practices, so the teacher sues him. If the teacher wins, the student must pay. But that victory also counts as his first case, meaning he owes nothing. If the student wins, he owes nothing by judgment. Both outcomes cancel the agreement. This paradox demonstrates how legal reasoning can trap itself through conditional logic. The contract depends on an event that destroys its own requirement. Each result satisfies and violates the condition at once. It shows that language built on self-reference can collapse under scrutiny. The rule works perfectly in form, but not in meaning. The paradox stays locked in contradiction because every valid outcome invalidates itself. Level 38. The preface paradox. An author publishes a book, believing every statement inside is true. In the preface, the author admits that some errors may still exist. Both attitudes, complete belief and partial doubt, are rational, but they conflict when held together. The paradox highlights how reason tolerates contradiction when absolute certainty is impossible. Each statement may be justified individually, yet acknowledging human fallibility means at least one must be wrong. The system of beliefs becomes inconsistent even though each part is sound. This situation appears in science, research, and everyday reasoning. People must act as though beliefs are true, while knowing some cannot be. Logic demands precision, but life requires acceptance of error. The paradox stands as a clear example of how rational belief can remain inconsistent without being irrational. Level 39, Meno's paradox. Plato described a puzzle about learning. If a person already knows something, inquiry is unnecessary. If they do not know it, they cannot recognize it when found. Learning seems impossible because knowledge must already exist for discovery to occur. The paradox challenges the process of education and discovery. Plato's solution suggested that knowledge exists within the mind, and learning is recollection, not acquisition. Still, the underlying logic persists. To search, one must know enough to form a question, but not enough to answer it. It shows how knowledge develops between certainty and ignorance. Learning begins from partial understanding, where the line between known and unknown stays blurry. The paradox continues to define how inquiry depends on incomplete awareness. Level 40, the paradox of the bridge. A philosopher faces a guard who enforces a rule. Anyone crossing must speak a true statement or be executed. The philosopher says, "I will be executed." If the guard kills him, the statement becomes true, meaning he should cross safely. If the guard spares him, it becomes false, requiring execution. Every possible action contradicts the rule. The paradox combines logic and consequence into a single loop. The truth of the statement depends on the result, while the result depends on the statement. The structure defeats itself, leaving no consistent path of action. It demonstrates how rules built on truth conditions can fail when applied to real decisions. Each step remains logical, yet together they destroy coherence. The paradox ends with the rule suspended, unable to resolve without contradiction. Level 41, the lottery ticket paradox. A person buys a ticket in a fair lottery with millions of entries. Mathematically, the chance of winning is nearly zero. It seems perfectly rational to believe that this ticket will lose. But if every participant holds that same belief, they all accept a statement that is almost certain to be true for each, but false for at least one. Someone will win, which means one of those reasonable beliefs must be wrong. The paradox shows how probability collides with logic. Each person's conclusion is justified based on the odds, yet all cannot be correct together. Rational belief can lead to a collective inconsistency. The reasoning that works for one individual breaks when shared by many. This contradiction questions how knowledge and probability coexist. It forces a distinction between being reasonable and being right. The ticket seems doomed by logic, yet statistics demand that one must succeed. Level 42, the simulation paradox. Suppose everything we experience is part of a computer simulation created by advanced beings. Every thought, sensation, and law of nature could be artificial. If such a discovery were made, the finding itself would also exist inside the same simulated framework, making verification impossible. The paradox lies in the idea of self-reference. Evidence for the simulation would belong to the simulation, and so could be fabricated by it. Every attempt to prove or disprove the theory becomes trapped within its own system of rules. Logic continues to function, but only under conditions that might themselves be illusions. It challenges what counts as real or knowable. Even perfect reasoning cannot break through the boundary of the environment it inhabits. The observer and the observed merge into one continuous system. The discovery of the simulation would not reveal reality. It would only confirm that there is no outside to step into. Level 43, Zeno's dichotomy paradox. A runner aims to reach a finish line. Before doing so, they must first travel halfway there. Before reaching halfway, they must reach a quarter of the distance, and before that, an eighth, and so on without end. The path divides infinitely. If space can be divided forever, motion should require crossing infinitely many points. Yet movement happens easily in the real world. This paradox highlights the conflict between mathematics and physical experience. Infinity, as a concept, does not match the continuity of motion. Mathematically, an infinite sequence of steps cannot be completed. Physically, the runner crosses the track in seconds. The two models describe the same act with incompatible assumptions. Zeno's reasoning exposes limits in how logic handles continuous change. Infinity exists in description, but not in action. The paradox dissolves not by solving it, but by realizing that motion belongs to experience, while division belongs to thought. Level 44, the Banach-Tarski paradox. In advanced mathematics, a solid sphere can be divided into a finite number of non-measurable pieces and reassembled into two identical spheres, each the same size as the original. The result follows strict mathematical reasoning, using the properties of infinity, set theory, and geometry. To ordinary intuition, the idea seems impossible. It suggests matter can be duplicated simply by rearranging parts, without adding volume or energy. This directly contradicts physical laws like conservation of mass. Yet within pure mathematics, the argument remains valid and internally consistent. The paradox exposes how different systems of reasoning lead to opposite conclusions about the same object. Mathematics operates on symbolic abstraction, not physical material. The sphere doubles, not by magic or creation, but through definitions that apply only in infinite sets. It separates the logical from the tangible, showing that not all truths can exist in the same world. Level 45, Newcomb's paradox. A person faces two boxes. One is transparent and holds $1,000. The other is opaque and may contain $1 million or nothing. A highly reliable predictor has already determined what the player will do. If the predictor foresaw that the player would take only the opaque box, it placed the $1 million inside. If it predicted that the player would take both boxes, it left the opaque one empty. The paradox begins with a simple question: should the player take one box or both? Logical reasoning splits into two opposing strategies. One path says to take both, since the contents are already fixed. The other says to take one, trusting the predictor's accuracy. Each argument appears fully rational, yet they cannot both be correct. This paradox tests the limits of free will and prediction. Perfect foresight erases genuine choice, while true choice undermines prediction. The boxes sit still, but the reasoning moves in circles. Level 46, Moore's paradox. Someone says, "It is raining, but I don't believe it is raining." The sentence is not logically inconsistent. It could describe a world where it rains, and the speaker holds the belief that it isn't. Yet, in real life, no one could say it sincerely. The statement is self-defeating when spoken. The paradox arises from a conflict between language and belief. Logic allows the statement, but psychology forbids it. The structure of the sentence fits grammar perfectly, but its meaning breaks the conditions of belief. To assert something, one must believe it, and so the sentence cancels itself in the moment of being said. It reveals a kind of impossibility that is neither logical nor physical, but mental. Some thoughts cannot be expressed truthfully, even when they make sense in form. The words align correctly, but the mind cannot stand inside them. Level 47, the black hole paradox. According to general relativity, anything that falls into a black hole disappears beyond its event horizon, and the information about it is lost. But quantum mechanics insists that information cannot be destroyed. This creates a direct contradiction between the two most successful theories in physics. The paradox centers on information loss. If data about matter truly vanishes, quantum law fails. If it somehow escapes, relativity's description of a black hole's boundary must be incomplete. Neither side yields without rewriting fundamental physics. The conflict reveals how gravity and quantum theory describe the same universe with incompatible rules. It remains one of science's deepest puzzles. Some theories suggest that information hides in subtle radiation, or that space itself stores it in a holographic form. Whatever the answer, The paradox shows that the universe refuses to let its secrets disappear entirely. Level 48. The infinite monkey theorem paradox. Imagine an infinite number of monkeys randomly typing on keyboards for eternity. Given limitless time, one of them will eventually produce every possible text, including the complete works of Shakespeare. The reasoning is mathematically sound, yet intuitively absurd. The paradox exposes the tension between probability and practical sense. Infinity makes every event possible, no matter how unlikely, but in any finite time, the same event would remain virtually impossible. Infinity erases improbability, collapsing rare and ordinary into the same category. It forces reconsideration of what it means for something to be likely or real. Infinite possibility does not guarantee meaning, only occurrence. The monkey's typing proves that randomness can produce order when time has no end. It writes not through intent, but through inevitability stretched across infinity. Level 49. The paradox of fiction. People experience real emotions toward fictional characters. They cry for imaginary losses, fear non-existent danger, and admire people who were never alive. Yet they also know these characters are not real. The same mind that disbelieves still reacts as if the events were true. The paradox lies in this dual awareness. Emotion responds to imagination as if it were reality, while reason insists it is not. Both operate at full strength without conflict. The contradiction is not in the feeling itself, but in how knowledge and emotion refuse to align. It shows how the mind holds multiple modes of truth. Fiction affects the nervous system, like fact, because the body does not distinguish belief from imagination. The character's reality ends with the story, yet the emotion it triggers remains genuine. Level 50. The simulation hypothesis. The simulation hypothesis proposes that an advanced civilization could create virtual worlds identical to reality. If even one such simulation exists, and many more can be made, then statistically, most conscious beings would live in simulations rather than in the original universe. The paradox questions what real means if perception and computation are indistinguishable. Every test we conduct would occur within the same framework we suspect to be artificial. Proof would therefore prove nothing beyond the simulation's own consistency. The observer cannot leave the system they inhabit to confirm what lies outside. It reframes existence as data rather than substance. Reality may simply be the experience of stable computation. Whether natural or simulated, the result feels identical. The world continues, running flawlessly on rules we cannot see. The illusion holds not because it hides truth, but because it perfectly imitates it. Level 51. The paradox of value. In economics, the paradox of value asks why necessities like water are cheap, while luxuries like diamonds are expensive. Water is essential for life, yet people pay little for it. Diamonds are unnecessary, yet valued far higher. This contradiction puzzled early economists, including Adam Smith, who noted that usefulness does not determine price. Instead, scarcity and marginal utility decide value. Water's abundance means that one more glass adds little satisfaction. Diamonds are rare, so each one holds high marginal benefit. Total utility explains water's importance, while marginal utility explains its price. What sustains life earns less than what decorates it, because markets measure scarcity, not significance. The paradox shows that value is not moral or intrinsic, it's situational. Price reflects desire under limitation, not need. A world flooded with diamonds would reverse the logic. What seems priceless or trivial depends entirely on what remains rare at the edge of supply. Level 52. Galileo's paradox. Galileo observed that while there are infinitely many natural numbers, there are also infinitely many perfect squares. Each square has one root, meaning both sets can be matched 1-to-1. Yet, intuition says there must be fewer squares than numbers overall, since most numbers are not perfect squares. How can a subset be as large as the set containing it? This paradox exposes the strangeness of infinity. In finite terms, a part can never equal the whole, but infinity ignores proportion. One infinity can contain another without size changing. Counting loses meaning when both the container and its subset extend without bound. Galileo's insight marks the beginning of modern set theory. It reveals that infinite sets follow their own rules of equality and comparison. Infinity behaves like a mirror. It reflects equivalence where logic expects difference. The squares are fewer in content but equal in endlessness, proving that infinity erases hierarchy. Level 53. The friendship paradox. In most social networks, the average person's friends tend to have more friends than they do. This result, though purely mathematical, feels psychologically off. Each person assumes they are typical within their circle, but the structure of social connections makes this impossible. Popular individuals appear in more friendship lists, meaning they weigh more heavily in averages. The paradox arises from sampling bias within networks. Because highly connected people are seen more often, they distort the average perceived from any single viewpoint. The individual's experience is mathematically accurate yet globally misleading. It reveals how perception interacts with structure. The illusion that others are more popular stems not from insecurity but from statistical design. Networks amplify visibility at their centers and hide isolation at their edges. The average friend appears more connected because they likely are. The paradox holds not in feeling, but in the geometry of connection. Level 54. The quantum measurement paradox. In quantum mechanics, a system exists in multiple states at once, a superposition until measured. Observation causes the wave function to collapse into a single definite outcome. Before measurement, an electron can be in many places. After, it appears in only one. This transition defies classical logic and creates one of the most profound paradoxes in physics. The contradiction lies in how measurement changes what exists. If observation produces outcome, then reality depends on interaction. But observers themselves are physical systems, so who or what performs the first measurement? The line between observer and observed dissolves. This paradox forces a re-evaluation of objectivity. Reality seems to require participation to manifest definite form. The act of looking defines what is there, while what is there defines what can be looked at. Quantum theory leaves no stable ground, only probabilities that solidify under awareness, then disperse when left unseen. Level 55. The paradox of free will. If every event follows causal laws, every human decision must be predetermined by prior conditions. Yet if actions are uncaused, they occur by chance, not choice. Either everything is fixed, or nothing is guided. Both options erase genuine agency. Free will appears impossible whether the universe is deterministic or random. This paradox sits at the crossroads of physics and philosophy. Determinism offers order but denies independence. Indeterminism offers unpredictability but denies control. The will seems trapped between chains and chaos. The paradox forces a redefinition of freedom itself. Perhaps free will is not exemption from cause but alignment with it, an ability to act consciously within constraints. The human sense of decision may coexist with necessity. The outcome might always be determined, yet the process of choosing remains subjectively real. Freedom becomes an internal experience of inevitability rather than its escape. Level 56. The observer effect paradox. In both physics and psychology, the act of observation changes what is observed. Measuring a particle alters its state. Studying behavior changes how subjects act. The paradox lies in the impossibility of passive measurement. To know something precisely, one must disturb it, creating a feedback loop between watcher and watched. In experiments, this effect limits precision. The more carefully we measure, the less natural the system becomes. In human studies, self-awareness alters authenticity. Observation injects presence into absence, forcing outcomes to acknowledge their witness. It reveals the boundary between objectivity and participation. The universe resists being seen without consequence. Data and interference become inseparable. Even silence or distance becomes a form of influence. Every act of knowing changes what is known. The observer and the observed never fully part, they exist as two ends of the same line, each shaping the other. Level 57. The paradox of identity over time. A person changes completely over the course of life, cells regenerate, beliefs evolve, and memories fade. Yet the law, society, and self-concept treat that person as one continuous identity. If identity depends on persistence, what remains when every component has shifted? The paradox exposes the fragility of continuity. Identity might rest in memory, pattern, or narrative, but each can be disrupted. A person with memory loss, or even total transformation, is still called by the same name. The essence of sameness survives without a fixed substance. Philosophers compare this to the ship of Theseus. Replace every plank, and it remains the same ship, only by convention. The self functions similarly, a reconstruction mistaken for permanence. Continuity is a story told by change. The paradox reminds that identity is not a thing we have, but an activity we perform endlessly. Level 58. The quantum Zeno paradox. In quantum mechanics, a system that is continuously observed cannot evolve. Frequent measurement freezes change, halting decay or motion that would normally proceed. This is called the quantum Zeno effect. The more we check a system, the longer it appears to stand still, contradicting the natural flow of time. The paradox arises because observation, meant to detect change, prevents it. Each measurement resets the system's evolution, locking it in its present state. Observation becomes a tool of immobilization rather than discovery. It questions the relationship between time, knowledge, and existence. Watching alters becoming. Attention suspends transformation. The more precisely we try to trace progress, the more we interfere with it. At quantum scales, knowing is an act of intervention. The arrow of time hesitates under the gaze that insists on seeing it move. Level 59. The Grelling-Nelson paradox. A word is called heterological if it does not describe itself. For example, long is heterological because it is not a long word. The paradox emerges when we ask, is the word heterological itself heterological? If it is, then it doesn't describe itself, which means it isn't. If it isn't, then it does describe itself, which means it is. The reasoning loops endlessly. The paradox captures self-reference in its purest linguistic form. It reveals how meaning collapses when definitions fold inward. The sentence consumes itself by applying its rule to itself. Logic turns circular and void. It demonstrates that language cannot fully regulate itself. Self-description generates contradictions that no system of grammar can escape. Words can classify the world, but not always themselves. The paradox exposes how semantics contains an inherent instability whenever thought tries to look directly into its own mirror. Level 60. The Berry paradox. Consider the phrase, the smallest positive integer not definable in under 12 words. That description itself defines the number in fewer than 12 words, creating contradiction. The act of naming breaks the rule it establishes. The number cannot exist because the definition erases its own boundary. This paradox emerges from the self-referential power of language. It shows that meaning can generate inconsistency when definitions become reflexive. Logical precision, pushed far enough, undermines itself. It connects deeply with limits in mathematics and computation, echoing Gödel's incompleteness and Russell's set paradoxes. Language can describe itself only until description becomes containment. The Berry paradox reminds that every system capable of expression hides sentences it cannot consistently manage. Definition becomes an act of destruction, where clarity dissolves into contradiction the moment it tries to define the undefinable. Level 61. Simpson's paradox. Simpson's paradox occurs when a trend that appears in several separate groups reverses when those groups are combined. In other words, an apparent relationship between two variables disappears or even flips direction when additional context is introduced. This contradiction often appears in statistics and data interpretation, where aggregation hides the influence of lurking variables. For example, a medical treatment might seem more effective in both men and women separately, but less effective when the data are merged. The paradox arises because group proportions differ, creating misleading overall averages. The individual results remain correct, but their combination produces a false impression. Simpson's paradox demonstrates that correlation is not inherently stable. The way data is grouped or separated can invert truth. It warns that context determines meaning and that averages can conceal structure. The numbers never lie, but they can easily contradict themselves through the lens that interprets them. Level 62, Olber's paradox. Olber's paradox asks why the night sky is dark if the universe is infinite and filled evenly with stars. If every line of sight should end at a star, the sky ought to blaze with light like the surface of the Sunday. Yet it doesn't. The darkness of night contradicts the assumption of an infinite, uniform, eternal universe. The resolution lies in cosmology. The universe has a finite age, and light from distant stars has not had time to reach us. Moreover, cosmic expansion stretches and dims light over distance. The night sky appears dark, not because stars are rare, but because the universe is evolving. The paradox exposes how a simple observation darkness contains cosmological truth. It shows that infinity cannot coexist with visibility under real physics. Space is not filled evenly, and time limits what light can tell. The void glows faintly only where history allows it. Level 63, Thomson's lamp paradox. Imagine a lamp switched on and off infinitely many times in 1 minute. On after 30 seconds, off after 45, on after 52.5, and so on. Each interval halves the previous one, filling the entire minute with infinite actions. The paradox asks, after 1 minute, is the lamp on or off? Logic breaks under infinite completion. Every switch changes the state, but the sequence never stabilizes. No final action exists because infinity has no endpoint. The lamp reaches the limit of time, but not of switching. It stands neither on nor off, but undefined. This paradox illustrates the conflict between discrete logic and continuous mathematics. Infinity defies closure while still occupying a finite interval. Thomson's lamp demonstrates that completing an infinite process within finite time creates contradiction. The lamp's final state cannot exist because infinity never ends, even when time runs out. Level 64, Brace's paradox. In traffic theory, adding a new road to a congested network can make overall travel times worse instead of better. Drivers, acting selfishly to minimize their own time, redistribute across routes in ways that increase total congestion. The new shortcut becomes a trap rather than relief. This paradox arises because individual optimization conflicts with group efficiency. When everyone pursues the best route for themselves, the network reaches an equilibrium that is globally worse. Removing the extra road can restore flow and shorten average travel times. Brace's paradox reveals the fragility of complex systems under self-interest. What seems like improvement at the individual level can degrade performance at the collective level. The paradox extends beyond traffic to economics, ecology, and communication networks, showing that more choice can sometimes mean less efficiency. The best path for one can block the best outcome for all. Level 65. Curry's paradox. Curry's paradox emerges from self-referential logic. Consider the statement, if this sentence is true, then Santa Claus exists. If the statement is true, then by its own form, Santa exists. If it is false, its condition holds automatically, again implying truth. Either way, the sentence forces its conclusion to be accepted. This paradox does not rely on negation or contradiction, unlike the liar paradox. Instead, it manipulates conditional logic itself. The self-reference turns implication into self-validation. collapsing the difference between proof and assumption. Curry's paradox reveals instability in formal systems that allow unrestricted self-reference. It shows how truth conditions can fold inward until they assert anything. Logical systems must restrict self-reference or risk explosion where any statement can become provable. It exposes that structure alone cannot protect meaning when language begins to talk about its own truth. Level 66. Wigner's friend paradox. In quantum mechanics, Wigner's friend imagines two observers. A scientist's friend measures a particle inside a lab, while Wigner observes the lab from outside. From the friend's view, the wave function collapses upon measurement. But from Wigner's view, the lab remains in superposition until he looks. Each observer assigns a different reality. The paradox questions whether measurement is absolute or relative. If both descriptions are valid, reality becomes observer-dependent. Quantum theory holds, but consistency between perspectives breaks. Wigner's friend extends the measurement problem into consciousness. It challenges whether objective truth exists independent of observation. In this setup, reality is no longer a fixed outcome but a relation between observers. The friend knows one truth, Wigner knows another. The universe holds both until someone asks which one counts. Level 67. Yablow's paradox. Yablow's paradox is an infinite version of self-reference that avoids direct circularity. Imagine an endless list of sentences, each saying, all later sentences in this list are false. No single sentence refers to itself, yet contradiction still emerges. If the first sentence is true, then all following ones must be false. But if all later ones are false, then the second sentence which claims the same must also be true, forcing the third to be false, and so on endlessly. The chain collapses without a base case. The paradox shows that circular reference can exist without direct self-reference. Infinity allows the loop to stretch infinitely far without breaking the cycle. It exposes that contradiction can hide in progression as well as reflection. Meaning unravels not because one sentence talks about itself, but because an infinite pattern makes self-reference unavoidable. Level 68. Parondo's paradox. Parondo's paradox occurs when two losing strategies, alternated in sequence, produce a winning outcome. It first appeared in game theory and physics, where random fluctuations can generate order. Each individual game guarantees loss, yet switching between them at intervals leads to gain. The paradox arises from non-linear interactions and cumulative effects. Context determines outcome. What fails alone can succeed in combination. Alternation converts local disadvantage into global advantage, revealing that randomness and structure can cooperate. It has applications in economics, biology, and thermodynamics, showing that variability itself can be productive. Parondo's paradox challenges the assumption that success depends on direct improvement. Sometimes, progress emerges only through oscillation between opposites. Losing can become winning when losses interfere constructively. Level 69. Gibbs paradox. In thermodynamics, Gibbs paradox occurs when two identical gases mix. Classical theory predicts an increase in entropy, the measure of disorder, yet physically, nothing has changed. Since the gases are indistinguishable, entropy should not increase, but the equations say it does. The paradox arises from how individuality is counted. Classical physics treats particles as distinct, while quantum mechanics recognizes their indistinguishability. Once corrected, the paradox vanishes, but the question remains, what does it mean for difference to disappear? Gibbs' paradox exposes how counting depends on meaning. When entities lose identity, the mathematics of disorder changes. It shows that even chaos relies on distinction to exist. The boundary between sameness and difference determines whether the world gains complexity or stays exactly as it was before the mix. Level 70. Burali-40 paradox. In set theory, consider the collection of all ordinal numbers, each representing a position in a well-ordered sequence. If we combine them into one set, that set should itself have an ordinal number greater than all others. But this new ordinal must also belong to the same set, contradicting its definition. No maximum ordinal can exist. The paradox shows that some totalities cannot exist even in theory. When a system tries to contain every instance of its own kind, it collapses. The set of all ordinals becomes too large to be a set at all. This paradox revealed deep flaws in early mathematics and helped shape modern axiomatic set theory. It demonstrates that infinity can exceed even itself. Trying to grasp all order produces disorder. The hierarchy of numbers folds under its own weight, leaving mathematics to rebuild its foundations on stricter ground. Level 71. Skollem's paradox. Skollem's paradox arises from the interaction between mathematical logic and set theory. The Löwenheim-Skollem theorem states that if a set theory has any model at all, it must also have a countable model, a version that can be listed in sequence. Yet within that same theory, there exist uncountable sets, such as the real numbers. How can a countable universe contain uncountable sets? The paradox exposes a mismatch between internal and external perspectives. From inside the model, the reals cannot be counted. From outside, they can. The contradiction comes not from mathematics itself, but from how models represent truth. It shows that formal systems depend on the viewpoint of their interpretation. Countability and uncountability coexist because language and structure are relative. Skollem's paradox doesn't destroy set theory, it reveals its limits. Infinity changes shape depending on where you stand to measure it. Level 72. Ross-Littlewood paradox. Imagine placing numbered balls into a jar. At each step, add 10 balls labeled 1 through 10, then remove the lowest numbered ball. Continue infinitely. At the end, how many balls remain? Intuition says infinitely many, but closer reasoning says none. Every ball is eventually removed, though infinitely many were added. The paradox reveals the fragility of reasoning under infinite processes. Each step appears valid, but the limit of all steps erases what seemed preserved. Infinity does not behave like arithmetic. The order of operations changes the outcome. It highlights the danger of extending finite reasoning into the infinite. Completion of endless tasks distorts logic, where doing forever and finishing after infinity are not the same. The jar begins full, ends empty, and never contains a final truth, only a limit that defies completion. Level 73. Maxwell's demon paradox. James Clerk Maxwell imagined a tiny intelligent being, a demon, controlling a door between two gas chambers. By letting only fast molecules through one way and slow molecules the other, the demon could separate hot from cold without using energy, apparently violating the second law of thermodynamics. The paradox challenges the idea that entropy always increases. If information can direct energy without cost, disorder could be reversed. But later physics revealed that the demon's act of measurement and memory storage consumes energy, restoring balance. Maxwell's demon illustrates that knowledge itself has thermodynamic consequences. Observation is not free, it carries an energetic price. The paradox helped bridge physics and information theory, showing that entropy and information are two sides of the same process. The demon never beats the law, it becomes part of it. Level 74. Allais paradox. In decision theory, the Allais paradox shows that people violate expected utility theory when faced with risky choices. Given two sets of lotteries with similar mathematical structure, individuals make inconsistent decisions, preferring certainty in one case and risk in another, despite identical probabilities when normalized. The paradox reveals that human reasoning about probability does not follow strict rationality. Emotion and context distort consistency. People overweight certain outcomes and underweight potential gains, showing that subjective value overrides formal logic. It challenges the assumption that rational agents maximize utility. Real decision-making involves psychological factors like loss, aversion, and perceived safety. The Allais paradox exposed a gap between economic models and human behavior, paving the way for behavioral economics. Rationality, it seems, bends around emotion more often than equations admit. Level 75. Ellsberg paradox. The Ellsberg paradox demonstrates people's aversion to ambiguity. When given two urns, one with a known 50/50 mix of red and black balls, another with an unknown ratio, most choose the known odds, even though the expected values are identical. Preference contradicts the laws of probability. The paradox shows that people prefer risk with measurable probability over uncertainty without one. Ambiguity triggers distrust in reasoning. This behavior violates expected utility theory, proving that humans value predictability itself. It reveals a deeper truth about cognition. Uncertainty feels worse than loss. Rational models treat missing information as neutral, but minds treat it as danger. The Ellsberg paradox reshaped economics and psychology by proving that emotion and uncertainty govern behavior more than logic or symmetry. Level 76. Goodman's new riddle of induction. Nelson Goodman introduced a challenge to the logic of prediction through the words green and grew. Suppose all observed emeralds so far are green, but define grew as green before time, t, and blue after. Both statements, all emeralds are green and all emeralds are grew, fit past evidence equally well. Which prediction is justified? The paradox questions what makes one rule more reasonable than another. Induction assumes the future will resemble the past, but that assumption itself lacks justification. Both green and grew describe reality correctly up to now, yet diverge later. Goodman's riddle shows that evidence alone cannot confirm meaning. It depends on the language and categories we use. Rationality depends on habit disguised as logic. The world's consistency may lie not in nature, but in the grammar of how we name it. Level 77. The boy or girl paradox. A family has two children. One is known to be a boy. What is the probability the other is a girl? Intuition often says 50%, but the correct answer depends on how the information is given. If the known child was chosen at random, the probability is 2/3 that the other is a girl. The paradox stems from conditional probability. The confusion arises because knowledge changes the sample space. Knowing one child's gender narrows possibilities unevenly. It is not the same as knowing the older child's gender or knowing there is at least one boy. The paradox reveals that probability depends on the structure of information, not just the event itself. Context defines the outcome. Simple questions about chance hide complex assumptions about what knowing means. The answer changes not with the children, but with how the fact was stated. Level 78. Bertrand's paradox. Bertrand's paradox involves selecting a random chord in a circle and asking, what is the probability that the chord is longer than the side of an inscribed equilateral triangle? Depending on how random is defined by angle, by midpoint, or by endpoint, the probability can be 1/3, 1/2, or 1/4. No single correct answer exists. The paradox arises from ambiguity in defining randomness. Different equally valid procedures yield different outcomes. The word random hides structure, and the structure shapes probability. It illustrates that probability depends on the geometry of selection, not just the event. Randomness without specification is meaningless. Bertrand's paradox warns that chance itself must be defined before it can be measured. Uncertainty begins not with outcomes, but with the assumptions that create them. Level 79. Jevons paradox. William Stanley Jevons observed that technological improvements that increase efficiency of resource use often lead to greater total consumption, not less. For example, making coal engines more efficient encouraged more coal usage by lowering cost and expanding demand. The paradox arises because efficiency changes behavior. When the same task costs less energy or money, people and industries expand usage. The intended conservation backfires into growth. Increased efficiency increases total consumption. It shows that optimization does not guarantee sustainability. Systems adapt economically, not morally. Jevons' paradox warns that progress can amplify the very problems it aims to solve. True reduction in resource use requires limiting demand, not only improving methods. Efficiency without restraint feeds its own undoing. Level 80. Street Petersburg paradox. In the Street Petersburg game, a coin is flipped until it lands heads. The payout doubles with each flip, $2, $4, $8, and so on. The expected value is infinite, yet no rational person would pay much to play. The paradox lies in the gap between mathematical expectation and real behavior. It reveals that infinite theoretical gain has limited psychological value. Diminishing returns and risk aversion shrink worth as potential grows. Expected value assumes linear utility, but humans weigh probability non-linearly. The paradox shaped modern economic theory by showing that value and utility are separate. Numbers alone cannot capture preference or emotion. The infinite reward exists only in calculation, not desire. Rationality bends where infinity meets human scale. Level 81. The voting paradox. The voting paradox, also known as Condorcet's paradox, occurs when collective preferences become cyclical despite individual preferences being rational. Suppose a group must choose among three options, A, B, and C. If most voters prefer A over B, B over C, and yet C over A, no consistent winner exists. Group choice becomes logically inconsistent even when every voter's ranking is coherent. The paradox exposes flaws in majority rule. Aggregating preferences can create contradictions where no option satisfies the whole. This instability appears in politics, decision theory, and even machine learning systems that aggregate human judgment. It shows that collective rationality does not guarantee logical consistency. Democratic methods can yield unstable or manipulable outcomes. The paradox forces reconsideration of fairness in voting. Systems that seem just may still cycle endlessly between outcomes. Rational individuals do not necessarily form a rational crowd. Level 82. The Doomsday Argument. The Doomsday Argument uses probabilistic reasoning to estimate humanity's total lifespan. It suggests that if you consider yourself a random human among all who will ever live, it's statistically unlikely you exist very early in history. Therefore, humanity is probably closer to its end than its beginning. The argument applies Bayesian inference. Given your birth rank, the total number of humans should not vastly exceed it. This leads to surprisingly short predictions for human survival, often interpreted as evidence that civilization's lifespan will be limited. The paradox lies in its self-referential probability. It treats existence as statistical evidence of humanity's timeline, blending observation with prediction. Critics argue that reference classes and assumptions distort meaning, while defenders claim the logic is purely mathematical. It challenges our sense of cosmic perspective. The doomsday argument turns existence itself into data about extinction, forcing reason to confront its own anthropic boundaries. Level 83. The inspection paradox. The inspection paradox appears in probability and statistics when random sampling favors larger intervals or groups. For example, most people will experience bus wait times longer than the schedule's average. The reason? Long intervals occupy more time, making them more likely to be observed. This paradox demonstrates how perception skews data. Observers naturally encounter situations weighted by duration or size, not frequency. In class sizes, average students see larger classes than teachers do. In traffic, drivers see more congestion than exists overall. The paradox reveals how averages depend on the frame of reference. What's typical for one perspective may be rare from another. It warns against trusting average experiences as objective. Observation itself is biased toward what lasts longest or happens most visibly. The world appears slower, larger, or busier than it really is, simply because that's when we're looking. Level 84. Bertrand's box paradox. In Bertrand's box paradox, 3 boxes contain coins. One has 2 gold, one has 2 silver, and one has 1 of each. You pick a box at random and draw a gold coin. What's the chance the other coin in that box is also gold? Many answer 1/2, but the correct answer is 2/3. The paradox comes from conditional probability. Drawing a gold coin increases the likelihood you chose the gold box. The initial probabilities shift after new evidence appears. The intuitive equal split between options fails because outcomes carry unequal information. It illustrates how probability resists naive reasoning. Evidence always reshapes likelihoods, even when choices seem fair. The paradox warns that partial knowledge changes truth. Probability lives in the relationship between observation and condition, not in the event itself. Level 85. The absent-minded driver paradox. A driver approaches a fork at night, but forgets which turn leads home. Each time he reaches an intersection, he chooses randomly, aware that he may forget again if he circles back. Even with rational strategy, his behavior never guarantees optimal choice because future memory loss alters planning. This paradox arises in decision theory when knowledge about one's own future actions becomes uncertain. The driver's rational plan cannot anticipate his own forgetfulness, so expected outcomes contradict logic. It highlights limits of perfect rationality under self-ignorance. Decisions require awareness of future states, but when memory or prediction fails, reason loops into contradiction. The absent-minded driver shows that knowing one's fallibility changes the meaning of rational choice itself. Strategy collapses when the strategist forgets. Level 86. The waiting time paradox. The waiting time paradox occurs when the average waiting time for a random observer exceeds the average interval between events. For example, people waiting for buses or calls tend to wait longer than the schedule suggests. Random observation favors longer gaps. Mathematically, the probability of arriving during a long interval is greater simply because long intervals occupy more time. The paradox inverts fairness. Most experiences occur in conditions less frequent but more extended. It reveals a deep bias in temporal sampling. Experience does not mirror reality evenly. It stretches around duration. The paradox challenges intuitive trust in time-based averages. What seems rare statistically can dominate perception because of its length. Reality feels slower than mathematics allows because observation weights the long and misses the short. Level 87. The EPR paradox. Proposed by Einstein, Podolsky, and Rosen, the EPR paradox questions whether quantum mechanics is complete. It describes two particles that remain entangled. Measuring one instantly determines the state of the other, even across vast distances. This spooky action, at a distance, seems to violate relativity's ban on faster-than-light interaction. The paradox challenges locality and realism. If measurement affects distant systems, then information travels instantaneously, or reality lacks independent properties before observation. Quantum experiments later confirmed entanglement, showing nature itself defies classical separation. It forces the choice between determinism and non-locality. The EPR paradox reveals that the universe may be connected in ways no signal can explain. Particles share a single state across space, behaving as one entity divided by distance. Observation breaks unity, but only by collapsing something that was never truly apart. Level 88. The no-cloning paradox. Quantum mechanics forbids creating an exact copy of an unknown quantum state. This rule, called the no-cloning theorem, contradicts classical intuition, where duplication seems trivial. The paradox arises from the linearity of quantum operations. Copying one state without disturbing it would require information that cannot coexist with uncertainty. The paradox reveals a fundamental boundary between classical and quantum information. In quantum systems, measuring to copy destroys the original. Duplication becomes transformation. Information can transfer, but not clone. It underpins the security of quantum cryptography and the structure of quantum communication. The no-cloning paradox shows that knowledge itself has conservation laws. Perfect copying violates the nature of quantum truth. Every attempt to reproduce reality changes it, leaving only entangled traces where identity once seemed simple. Level 89. Loschmidt's paradox. Loschmidt's paradox asks how irreversible processes, like entropy increase, can arise from time-symmetric physical laws. If all molecular motion obeys reversible equations, why does heat flow one way from hot to cold and not the other? Reversing all velocities should restore order, but nature refuses. The paradox reveals that statistical likelihood, not mechanical law, defines the arrow of time. While microscopic rules are symmetric, macroscopic behavior overwhelmingly favors disorder. Entropy increases because ordered states are fewer, not because time enforces direction. It connects thermodynamics with probability, showing that irreversibility emerges from vast numbers, not forces. The paradox reminds that the universe's flow from order to chaos is not imposed. It is simply the most probable path through an infinite landscape of microstates. Level 90. Lindley's paradox. Lindley's paradox exposes a clash between Bayesian and frequentist statistics. A result can be statistically significant under traditional hypothesis testing, yet still have high probability of being false when viewed through Bayesian reasoning. The paradox arises when large sample sizes magnify small effects. It demonstrates that significance does not equal certainty. As data grows, even trivial deviations become significant, but Bayesian inference discounts them if prior belief favors the null. The same data lead to opposite conclusions depending on interpretive framework. The paradox shows that probability is not objective. It depends on assumptions about belief and evidence. Lindley's paradox warns that data alone cannot determine truth. Interpretation gives numbers meaning, and different philosophies of reasoning yield different realities. In science, logic itself can disagree with its own math. Level 91. The Munchausen trilemma. The Munchausen trilemma argues that any attempt to justify knowledge inevitably fails by falling into one of three traps: circular reasoning, infinite regress, or dogmatic assumption. If every statement requires proof, then justification must either loop back to itself, continue endlessly, or stop arbitrarily. The paradox takes its name from Baron Munchausen, who claimed to pull himself out of a swamp by his own hair, a metaphor for reason trying to validate itself. Logic cannot ground itself without appeal to something outside its structure. It exposes the limits of epistemology. Every system of knowledge rests on unprovable foundations. The trilemma forces acceptance that certainty is impossible, only coherence or usefulness remain. The paradox doesn't destroy truth, but reveals its architecture built not on infinite proof, but on chosen trust. Reason, like Munchausen, can only lift itself so far before relying on belief. Level 92. The information causality paradox. The information causality paradox tests the boundaries of quantum communication. In classical physics, transmitting one bit of information cannot yield more than one bit of knowledge. Yet quantum entanglement seems to allow correlations that share more knowledge than information sent, without transmitting data directly. The paradox arises because quantum mechanics permits non-local correlations that appear to violate causal limits. Two distant observers can produce correlated outcomes without exchanging classical signals. It suggests that information behaves differently from matter or energy, hinting that the universe encodes causality in unfamiliar ways. Information causality restores order by imposing a constraint. No physical theory should allow communication beyond classical limits. The paradox highlights tension between non-locality and information theory. Reality shares connection without exchange. Quantum systems coordinate outcomes across space, yet never carry messages faster than light coherence without communication. Level 93. The Boltzmann brain paradox. The Boltzmann brain paradox arises from thermodynamic probability in cosmology. In an infinite universe governed by random fluctuations, it is statistically more likely for a single self-aware brain to appear spontaneously from chaos than for an entire structured cosmos to exist. If so, we should expect to be disembodied brains hallucinating reality. This idea undermines the credibility of observation itself. If consciousness can emerge from entropy randomly, any apparent universe becomes suspect. Experience loses evidential power because illusion outweighs order by probability. The paradox confronts the meaning of existence in probabilistic universes. It implies that order might not be the rule, but the rare exception mistaken for normality. Physicists counter by proposing cosmologies that suppress such fluctuations. Yet the paradox endures as a warning. If randomness dominates infinity, even reality cannot trust its own mind. Level 94. The measurement problem paradox. In quantum mechanics, the measurement problem asks how a superposition of possibilities collapses into a single observed outcome. Before measurement, a particle exists in many states, afterward, only one. The paradox lies in how observation triggers transformation. What mechanism chooses one result among all potential ones? Different interpretations attempt solutions. Copenhagen claims observation causes collapse. Many worlds says all outcomes occur in separate realities. Objective collapse theories invoke spontaneous physical processes. None eliminate mystery entirely. The paradox exposes the boundary between mathematics and experience. Quantum laws predict probabilities, not realities. Yet measurement produces a definite world. The act of observation seems to bridge mind and matter, introducing subjectivity into physics. The universe works flawlessly until it is asked what it is doing, then it must decide. Level 95. Moravec's paradox. Moravec's paradox reveals that tasks humans find effortless, like perception, movement, and recognition, are extraordinarily difficult for computers, while complex logical or mathematical reasoning is relatively easy. Evolution optimized brains for survival, not abstract thought, making the simple tasks computationally vast. Robots can solve equations, but struggle to identify faces or walk naturally. The paradox arises because intelligence evolved bottom-up. Sensory and motor skills encode millions of years of refinement, while logic is a recent, lightweight addition. It exposes a mismatch between intuition and complexity. Human effortless skills hide enormous neural computation. Artificial intelligence reverses that order, mastering reasoning before understanding perception. Moravec's paradox reminds that what seems simple to humans represents the deepest achievement of evolution, while intellect may be the easiest trick in a body already built to move, see, and feel. Level 96. The relativity of simultaneity paradox. In Einstein's theory of relativity, two events that appear simultaneous in one frame of reference may occur at different times in another moving frame. The paradox arises because simultaneity, once considered absolute, becomes dependent on motion. What is now for one observer may be before or after for another. This relativity of time challenges intuitive sequence. Events lack universal order, only light signals, and causality preserve consistency. The paradox seems to contradict common sense, but aligns perfectly with space-time geometry. It reveals that time is not global but local, stretched and skewed by speed. Simultaneity dissolves into perspective. The paradox shows that present has no universal existence. Every observer lives in a private temporal slice. Time's flow, once singular, fractures into countless overlapping timelines tied to motion itself. Level 97. The observer self-reference paradox. The observer self-reference paradox arises when a system tries to describe itself completely. Any observer included in their own observation distorts it. Measuring oneself changes the state being measured. Consciousness adds further recursion, self-awareness, watching itself think. This paradox appears in philosophy, logic, and AI. In mathematics, self-reference breeds inconsistency. In cognition, it spawns infinite regress. Observation turns inward until it collapses into indeterminacy. To know oneself fully would require a perspective outside oneself, which cannot exist. It highlights the recursive limit of understanding. Systems can model everything but themselves without distortion. The paradox exposes that awareness is both the subject and the instrument of knowledge. Self-reference defines intelligence but also its boundary. Every mirror eventually reflects itself reflecting. Level 98. The infinite regress paradox. The infinite regress paradox questions how explanations, causes, or justifications can ever end. Every reason requires another to support it, forming an endless chain. To stop the regress, one must either accept an uncaused foundation or admit incompleteness. This paradox haunts philosophy, theology, and logic. Whether explaining the universe, morality, or reason itself, the question why leads backward without closure. Infinite explanation defies comprehension. Finite stopping points seem arbitrary. It demonstrates that ultimate justification cannot exist within the same system it explains. The paradox forces acceptance that some truths must stand without further cause. Inquiry can approach infinity but never conquer it. Every explanation eventually meets silence. Level 99. The Many Worlds Probability Paradox. The many worlds interpretation of quantum mechanics claims that every possible outcome of a quantum event occurs in a separate universe. But if all results happen, what does probability mean? How can we speak of likelihood when every possibility is realized somewhere? The paradox arises from trying to preserve statistical meaning in an infinite multiverse. Standard probability collapses when existence contains all alternatives. Why should one experience correspond to one branch over another? Physicists propose that amplitude measures subjective expectation rather than objective frequency, but consensus remains elusive. The paradox questions whether probability describes reality or perspective. In a world where everything happens, randomness becomes partitioned. Experience an illusion of choice in an ocean of certainty. Level 100. The Anthropic Principle Paradox. The anthropic principle states that the universe must allow observers to exist because only such universes can be observed. The paradox emerges when this explanation replaces cause with necessity. We see a life-friendly universe because we could not see otherwise. This reasoning explains everything and nothing. It blurs the line between logic and tautology. The principle seems profound, but risks circularity. Life exists because the universe permits it, and the universe is observed because life exists. It avoids falsification by defining observation as inevitability. The paradox exposes the limits of reasoning from existence. Observation cannot distinguish coincidence from condition. The anthropic principle fits every universe that contains observers, explaining no particular one. It comforts by necessity, not by cause. The reasoning folds inward, leaving the universe both inevitable and unexplained. Thank you for listening. I hope you learned something new tonight. If your mind is still awake, that's okay. Just let your thoughts slow down and your body rest. Even closing your eyes and breathing is enough. If this video helped you relax, you can like and subscribe to see more.